Are you ready to learn the spectacular truth about the moon? What secrets and dangers really lie dormant at the poles of the satellite? And why is an astronaut visiting these regions being roasted alive? Hit the like and subscribe buttons and stay tuned until the end. We'll show you now. A mystery solved? The moon has always exerted a special attraction on Earth, both literally and always figuratively. Every night, our constant companion advances to become the largest and brightest structure in the firmament. And while the mystical celestial body is known to be directly involved in the interplay of our earthly tides, some people even believe that a universal force emanates from it that affects personal well-being. But even beyond the sleepless nights of the full moon and eerie werewolf legends, the Earth's only satellite is repeatedly the focus of interest. And this by no means only refers to the revolutionary moon landing in 1969, when Neil Armstrong and Buzz Aldrin were the first humans in history to set foot on a foreign celestial body. No, the future of space travel has also already been plunged into a lunar shadow. When it comes to colonizing the remaining celestial bodies of our home system, our satellite seems to embody a logical first-stage destination. And this despite the fact that it has been more than 50 years since man last set foot on the moon. Since NASA astronaut Eugene Cernan left the dust-covered surface of the moon on December 14, 1972, the celestial body has been waiting in vain for further visitors. Until today, the question why we have not returned to the satellite since then is accompanied by massive riddles and discussions. The corresponding explanations refer to the immense costs, the dangerous radiation, as well as the lack of interest. Accordingly, we should not forget the historical context in which the short age of manned moon landings fell. If we turn back the wheel of time to July 20th, 1969, we land, as we know, in the middle of the Cold War. More precisely, at the spectacular finish line of the space race. As the US had brought the Soviet Union to its knees technologically, interest in future lunar visits ebbed noticeably within a few years. The politically motivated goal had been achieved, and moreover, scientists believe that the soil and rock samples that would be collected during the Apollo missions were enough to fully decipher the celestial body. However, the stunning discoveries of the recent research past prove that this was a fatal fallacy. From traces of water to ominous glass spheres to a gigantic cave complex, the Trabant once again shows us how many secrets are still slumbering under our earthly noses. Renaissance of the Moon missions. In recent years, the view of space agencies on the moon has changed. Despite all the SpaceX rockets that exploded during launch and the failed Hakuto R probes, several nations are making plans to establish permanently manned lunar stations. However, these ambitious projects are based not only on scientific curiosity, but in particular on the realization that the moon is rich in raw materials that need to be extracted commercially. If you like, the moon currently resembles an untouched treasure chest. Whether it's iron, titanium, gold, platinum, or iridium, the list of metals suspected to be found in abundance on the moon is long. No less coveted is helium-3, a lighter variant of the well-known noble gas that is extremely rare on Earth. And lunar water ice is also arousing the desires of the leading space nations. Currently, experts believe that the moon harbors about 600 billion kilograms of the frozen substance. In view of the fact that the thermometer on the day side of the moon scratches at the 130-degree mark, the question arises as to how the celestial body can possess such a large quantity of ice at all. Shouldn't it have evaporated long ago and escaped into the vastness of space? Well, not quite, because actually the temperature differences between the day and the night side of the moon are extreme. Thus, the thermometer falls in that area, which lies temporarily in the shade, up to 160 degrees Celsius under the freezing point. Basically, scientists assume that billions of years ago, one or more water-containing comets hit the satellite As a result, the substance was deposited in the craters and depressions of the polar regions, and because of the moon's low inclination, some of these formations have not seen sunlight for millions of years. Lunar hurdles. When NASA's Lunar Reconnaissance Orbiter explored the moon's poles, it recorded bone-chillingly cold temperatures there, as low as -238 degrees Celsius at the South Pole and -247 degrees Celsius at the North Pole. If we want to turn the dream of colonizing the moon into reality, the use of the water there is of essential importance. And this by no means only means supplying the astronauts with drinking water. No, the water ice could even be used to produce oxygen and fuel. However, the extraction of water ice could turn out to be much more difficult than initially assumed. This includes not only the extreme cold at the poles, but also electricity. As a result of the low inclination of the moon, the solar winds, which consist mainly of ions and electrons, pass the polar regions and the day-night boundary almost horizontally. In turn, they strike the sides of the craters away from the wind, causing the negatively charged electrons, which are 1,000 times lighter than the positively charged ions, to literally sink into the depressions. Consequently, the affected surfaces become negatively charged, creating a charge difference that in turn forms an electric field. In detail, the separation between electrons and ions eventually reaches a critical level so that these areas can become charged with hundreds of thousands of volts. For a careless researcher, therefore, a direct visit to the poles could quickly have fatal consequences. But even if we avoid setting foot on the poles, the electronic danger on the moon is far from over. As is well known, the celestial body is not only home to water ice and charged death craters, but also to dust as far as the eye can see. Dust storms. What is popularly known as lunar dust goes by the scientific name of regolith. Basically, this term covers that blanket of loose material that we find on the other rocky planets and moons of the solar system. The fact that the tiny, sharp-edged particles are justifiably suspected of causing dangerous respiratory diseases has been known for some time. The fact that the fine, sticky substance also has another, no less serious property, however, is less so. Since the moon has no magnetosphere, the solar wind hits the surface unfiltered. Since that surface is negatively charged in the course of this, the regolith becomes electrostatic. This is also the reason why the moon dust sticks to everything it touches, a circumstance that already amazed the astronauts of the Apollo 11 mission. The result was contaminated spacesuits that carried the substance into the lander, where it triggered a kind of lunar hay fever in the space travelers. In detail, the spacesuits of Neil Armstrong and company were made of woven Teflon, a material that attracts the electrostatic regolith and encloses it. Furthermore, the material can also cause a so-called triboelectric effect, the phenomenon when we rub our feet over a carpet, then touch the metal handle of a door and feel a small electric shock. If the research work of a lunar astronaut were accompanied by regular shocks, such missions would be infinitely more complicated. But then how did it actually happen that the 12 people who had been on the moon so far were not constantly shocked? Well, this was related to the carefully selected landing sites. Thus, this unwelcome effect can be compensated for when the photons emitted by the sun release such electrons from the soil, a process known as photoelectric emission. Because the Apollo missions were all completed on a part of the moon that was in the constant glow of the sun, the risk of electrocution to the astronauts was very low. Plans for the future. But how can we protect future lunar visitors from the moon's extreme temperatures and toxic dust? Well, regarding the question of a perfectly air-conditioned location, current experts are focusing on the lunar lava caves. Those underground passages once formed by fast-flowing lava streams could be characterized by comfortable temperatures in the range of 17 degrees Celsius. Well, if they really exist in the presumed form. Up to now, the circular collapse holes, which are presumably above the caves, are the only indication which we could collect in this regard. If one follows the explanations of experts, however, these are most likely the collapsed ceilings of former lava passages. To date, at least 16 of these so-called skylights have been located on the lunar surface. With diameters of 15 to 150 meters, these formations could embody the natural gates to partly gigantic cavities in the underground, which simplify the future of the moon settlement extremely. Regarding the regolith, new spacesuits with dissipative, or in other words, electronically dissipative properties must be developed. As a tried and true insulating all-rounder, one might initially think that rubber is the material of choice here. However, this decision would have to be weighed against the extreme temperature fluctuations to which the astronauts are exposed on the lunar surface. Several projects are currently working on a solution to this and other problems. For example, a team at Washington State University received $130,000 to explore the extent to which liquid nitrogen can be used to address the regolith problem. But a technology consisting of electrodynamic dust shields, which are made up of electrically charged panels, is also currently being put through its paces. True to the motto, where humans would put themselves in danger, machines would do better, the Norwegian company Intention is working on a project that will enable missions to be carried out remotely. The special human-machine interface will allow astronauts to control rovers and robotic arms over long distances. Thanks for watching our video to the end. Feel free to leave us a thumbs up and subscribe if you liked the post. And now it's time for your opinion. What do you think about the amazing properties inherent in the moon's poles? And what goes through your mind in view of the planned mining of raw materials?